We have a bit of an action-packed lineup today. We're going to be hearing from Erica Legara of AIM first up, and I'll introduce her more formally in a moment. She's going to talk briefly about the data science industry in Philippines and Singapore, and also the new program that they have here at AIM. We're going to hear from one of the top data scientists in the Philippines, Mr. Joe Brillantes, who's going to tell us about kernel density estimation applied to Metro Manila road accidents. After that, we're going to have a bit of a break, and I can assure you there is plenty of food and pizza and drinks. Questionable nutritional value, but let's ignore that for now and eat to your heart's content. It's I'm not going to say it's all you can eat, but yeah, you can treat it as all you can eat. So we'll have a break for food. Then we will hear from Hans Hermida, who is the Cloud and Enterprise Manager at Microsoft. And they are our platinum sponsor for tonight, so many thanks to them for helping us out with the food and drinks for tonight. Hans is going to tell us about some of the exciting stuff they're working on. And then we will hear from another one of the top data scientists operating in the Manila market, JP Domingo. Data science at Nielsen, who's going to be walking us through some real-world battle stories of working in analytics and data science in Manila. But first up, we will be hearing from Erica. Erica has a strong research and innovation background. She was a research scientist at the leading government think tank in Singapore for 5.5 years and has been a complex systems researcher for 11 years now, since 2006. In addition, she has a wealth of experience engaging and collaborating with entities from various businesses, industries, and government agencies, helping them to innovate and adopt data-driven approaches in their systems and processes. So we're very privileged to be able to hear from Erica today. Over to you, Erica.
Thanks so much, Isaac. I was just informed that you were going to have this event here today. I just moved back in July this year to start the very first formal data science degree, right, in the country, which is a master's in data science at AIM. So I wasn't really sure about the audience. And when I heard kernel density function as one of the talks of Joe, and I was like, oh my God, these are technical people. Are you technical people? Yeah, because in the last month, so some of you might find the presentation corny or not too challenging for some, because I wasn't really expecting what kind of audience I was going to talk to. But hopefully, I'm going to show a bit of research that we did in Singapore. Hopefully, it will challenge you. It's in the data science realm, but doing a lot of multi-agent-based modeling. Anyway, so yeah, I'm Erica. I'm on Twitter, EF Legara. I am the program director for the Masters of Science in Data Science at AIM under the School of Innovation, Technology, and Entrepreneurship. We also have another program which is Innovation and Business, and our students are going to work closely together. So it's going to be an exciting 2018 for AIM. The clicker, okay. So, like what Isaac said, I'm a physicist by training. I have a PhD in physics and a complex systems scientist. In the next 2 slides, I'm gonna explain what that means, if you don't know yet. And I was based in Singapore for 5.5 years, working at a government think tank, which is the Agency for Science, Technology, and Research. We built models, not just data science models, not just machine learning models, but really from mathematical to statistical to physics models and all that jazz. Because of this, it allowed me to work with a lot of data. So that's how I got into data science, because everything was data-driven. And yeah, like what I said, 2 months ago, I joined AIM. I've been to a lot of meetings with businesses and agencies. That's why the nature of my talk is a bit, for the layman. I hope that it's okay. So this is complex systems. In our team, my former boss, Chris, is actually here. He's now heading the School of innovation, technology, and entrepreneurship here at AIM. We pirated him back to the Philippines. Our complex systems team, we all have these different capabilities like nonlinear dynamics, systems theory, pattern formation, network science, collective behavior. So what this just means is that most of the systems in the real world, you cannot just study them isolatedly, right? Like individually in silos. Like when you talk about traffic. Traffic is influenced by a lot of other systems. Do you agree? Yes, you're still with me. This is still the second slide. So yeah, when you talk about complex systems, these are the different fields. And can you see from the back? No, sorry. Under evolution and adaptation, this is where artificial intelligence and machine learning, they all come in. So in our team back in Singapore, there was like 16 of us, right, Chris, in the team, and most of us have different backgrounds. So I'm very comfortable working closely with computer engineers, computer scientists, economists, statisticians, because most of the fun subjects are actually within the realm of interdisciplinary research. Do you agree? Yes, you're all nodding. Thank you. So this is the actual talk. Data science in the real world. You know that the world is getting smarter and smarter and smarter. You know, in Singapore, we talk about wanting to be the very first smart nation in the world. Well, it's just one city, but still, it's a nation. So we also have smart sensors, smart manufacturing, smart farming. Why do you think this is the case? Because we are producing so much data, right? And with so much data, we get to understand the world around us better, like how people interact with people, how people interact with machines, and how machines interact with other machines. That's what we call the Internet of Things. And just so you can have an idea of how big this data is, I don't really like using the term big data, but anyway, how big the data is, if you're gonna add up the total amount of data from 1,000, 2,000, 3,000 years ago, if you're gonna add them all them up, 90% of the entire data set were just created in the last 2.5 years. Who knew this trivia? Alam niyo ba tong fact? Who knew this fact? Show of hands. Oh, not a lot. Oh well, that's something you can tell your seatmate later when you go home in a commute. So this is the kind of data that we are producing every 60 seconds. You cannot see, but if you want to chat, I can tell you a lot more statistics. But these are just some of the data. So when your friends ask you, what are the different types of data? There's the activity data. These are data that you produce, for example, when you use your credit card, when you use your ATM cards, when you withdraw, all the transactions that you make, they are all activity data. When you use your beep cards, when you tap in a station and tap out of a station, these are all activity data. Conversation data, that's pretty straightforward, right? And then you also have the photo and video image data, and finally sensor data. You know, in the Philippines, there's been a lot of buzz around data science because of the BPO industry and Industry 4.0. Who here has heard of Industry 4.0? Yay, wala masyado. At least this is not something very redundant. So it's the fourth industrial revolution, wherein machines talk to machines and then they try to decide for a specific, process in a manufacturing industry or a factory or a firm. Okay, so this is where sensor data comes in. Our cell phones alone, those who are using smartphones, inside your cell phones, there are over 10 to 15 sensors, your smartphones alone. And this is one of the examples I really like because I didn't know about this prior to doing this slide. You know, a Boeing 737 has 2 engines. Each of its engine is producing 20 terabytes of data per hour. Each engine yan, And then you have 2 engines, that's around 40 terabytes of data. And when you fly from LA to New York, that takes around 6 hours. And in 1 year, this is the amount of data that the airline industry is producing. That's a lot of data, and that's just one industry. Okay? But like what I mentioned earlier, I don't really like to call it big data. Who's this? Big data. Oh, konti lang nakagets. But that's, all right, so you're not that dorky after all. Big data is not about the amount of data that you have. I've seen one of Isaac's presentation. He also stresses this out. It's not about the amount of data. So what is it really about? For me, I define data science as something where you use data to answer specific questions for your company, for your industry, for the government. It's all about filtering these data sets and then, cleaning them. You always hear about unstructured data. We're collecting all this data, but then most of them really are not useful. So this is where data science comes in. And this is just a very soft definition, very loose definition of what data science really is. It's about extracting and cleaning data, looking for patterns in your data, building predictive models. And when you talk to a physicist like me, when we say predictive models, it's not just machine learning, it's not just artificial intelligence, but it's a lot more than that, like agent-based modeling, multi-objective optimization, all these models, all right? And of course, I think data series is very good at, this is a super important part as well. If you have results, they have to be actionable. You cannot just give your boss plots and then some results from your machine learning model. Hey boss, I'm so cool. I used convolutional neural nets, blah, blah. And then the results, they don't make sense. They don't do anything for the business. So that's why communicating data-driven stories is very important, and I'm very happy that Data Series is really helping to educate a lot of people about communicating what your results are, right? So that your company, your bosses can make data-driven decisions. Do you agree? Okay. Have these guys eaten yet? Have you? Yeah. Anyway. So data science has been used across industries. That's what I love about data science, because as a researcher, I tend to get bored easily, but then data science cuts across industries. So there would be a time when I would be talking to government officials. There would be moments when I would be talking to bankers. And then, so it really cuts across industries like smart cities, fraud detection, fintech, telcos, retail. So these are just some of the examples where data science can be useful. I'm just going to give you some concrete numbers on where data science has been very effective. For example, in this one, this is a US bank. Maybe some of you have heard of this. They use data science to increase fraud detection by 15%. Equally important is the reduction of false alarms by 50% and increase in total savings. Another example that I love sharing to people is this UK company called Parts Alliance. It's an auto parts distributor. They didn't have to buy new equipment. What they did was they hired, in fact, in the article, it says junior data scientists, whatever that means. So they hired junior data scientists, and these data scientists, what they did was they looked across 20 million historical transactions of purchase patterns. And from there, they were able to identify which specific product to sell at a discount. Yun lang, that's it. No new equipment, no GPU farms, nothing of this stuff. But they were able to boost revenue by 30%, which is equivalent to around 6 million British pounds. That's data science. Another example, Pirelli. It's the 5th world's largest tire manufacturer. Who here knows about Pirelli? Konti. They're the only tire manufacturers for F1 cars, okay? Mostly luxurious cars. A few years ago, they just started the data science team. And within 18 months, all right, when they started their data science team, they were able to increase manufacturing efficiency. Overall scrap reduction 15%, decreased cycle time by 2%. And then you might think, well, 2% is really small. But no, 2% translates to 100,000 tires per factory per year. So that is a lot of tires. And as well, improve demand forecast. Another example, this is what my colleagues did at the Agency for Science, Technology and Research in Singapore, wherein they optimized the different operations within the port port industry in Singapore. You know, Singapore is rich. One of the reasons why is because they have a very efficient port industry. You know, the ships would dock, and then you'd have cranes picking up different containers. All these need to be optimized. Do you agree? Yeah? So they were able to do this and reduce the waiting time and handling times of ships concurrently. They cannot afford the seaports to become clogged and congested. All right? And another example is the machine health monitoring. There's been a company here in the Philippines who has expressed interest to work with us here at AIM, essentially because of this. So what they do here is they use neural network to predict the health of a specific part of a machine. Why is this important? Because if you have a production line and you don't know the health of the different parts of your production line, if they break down, what happens? It can be very catastrophic, right? But if you get to predict 1 month ahead, 2 months ahead, that hey, the health of this specific part is, you know, not so good, that maybe we should start ordering a new set of parts. So again, that's data science and more. But this is what I want to share with you, just so you get to be convinced that I'm not just a businesswoman. I'm not a businesswoman. I'm a scientist. So what we did here in Singapore was we developed a transport simulation tool for scenario analysis. This is what I'm saying. This is not just data science anymore. But before we got to where to our deployable platform, we did a lot of data science behind it. So I'm just going to show you. So we produced 3 publications from this work, and I think more, right? So a client came to us with data. What kind of data? The beep card data, but Singapore-based. The Singapore EasyLink card used for the train system, but also for the buses. And sometimes you can even use it to pay taxis. So it's that efficient. So we were given this data set, and their question was, what are the critical origin and destination pairs within the Singapore MRT system? All right, so I ask this to you now. If you think you're a data scientist, think about these questions. How do we probe the route choices of commuters? Just by knowing the origin and destination. Okay, the time of tap in, the time of tap out. How can we model various scenarios such as travel delays resulting from overcrowding of platforms? Who rides North Edge? What's the busiest station dito? Huh? Okay, you don't know. Akala ko data scientist kayo. You don't even look at data. You just use your intuition. Anyway, how often are people unable to board the train? So if they pass, full, you cannot ride. Another train, full. So how many times? And can we identify tipping points in the system? When we say tipping points, it's the capacity of the system. If we don't change or improve the infrastructure and there are more people riding the train, up to what point can we accommodate such that the quality of service is still good? So these are their questions. And can we predict the efficacy of congestion reducing strategies? I give you 10 seconds. Just look at the questions and where your data scientist hat. How do you think you would solve this? What would you do first? I'm not going to give you the answer. I just want you to think, okay? But so this was a 2-year project. This is a real-world data science question. That's the thing. They don't tell you what method or model to use. Most of the data science guys here in the country, I noticed, they're very good at machine learning and neural networks, but only if they're told what to implement. But in the business world, in the real world, these are the questions that they give you. They don't even tell you if their data is clean or not. They don't tell you if you should use mathematical models or statistical models or machine learning or SVM versus the ensemble decision trees. They will not tell you. It will be up to you to decide what kind of model you're going to use. That's the real world. All right, so at the end of the day, we were able to build this. Chris and I started to build this using Python. But then we eventually had to scale up. So we hired one of the best software engineers and data scientists that I know of, who's a Singaporean, to build this model. So these are the different stations in Singapore. The big circles are the MRT. The small circles are the bus stops. So what this gives you is a bird's eye view of how long it takes to get from one region of Singapore to another region in Singapore. But what you're seeing here is purely data visualization. This is not the heart of the platform that we build. The heart of the platform we built is the simulation part, and this is what you see now. So what we did here was agent-based modeling. You can see this is like SimCity, right? So the triangles moving are the trains, the smaller triangles moving are the buses, and you can see the people moving in and out of the stations. They all reconstruct what is happening in the real world. So we use data to build these kinds of models. And it tells the stakeholder what is really happening at a specific time of the day at a specific station, whether or not the station is full or whether or not it's not. So the sizes of the different objects tell you how many people are inside it. So you can just look at the statistics here to your left. It tells you the number of people, it's not so nice, number of people tapping in, tapping out every 10 minutes, number of people who are waiting at the platform. And the nice thing about this is that we can click at the station and simulate a breakdown, like what we did here. So what if there's a breakdown in Clementi Station? What happens? So you can see that not only this is clogged, but also this station here is clogged. Why is this important if you're a policymaker? Because if you want to deploy shuttle buses to pick up those who are stranded, you know that it's not just the adjacent stations that are affected, but also other stations that are far away. And because of this platform, they could easily plan where to deploy these stations. And these are just some of the capabilities. And if you work with real-world companies and industries, it's important that your results are validated. Sorry, this doesn't work. So we have a validation part there. Hindi lang, it's not just a toy model. It has to be something that you can show actually reconstructs what you are observing in the real world. So this is what we did. And what are the other things that we can do? This is what I meant when I was talking about real insights. I don't think Isaac will like this because it's not very, this is what I'm saying. So if you're gonna send this to your boss, it's like, what does that mean? Duh. Anyway, I just wanted to show this slide to let you know that the one that you saw, it's pretty, but there was a lot of math and science that went behind it, okay? And the math and science that went behind it are mostly novel, so we were able to publish internationally peer-reviewed papers. So what were the things that we did there? The shortest path, how people choose their routes, okay? What are the different statistics that we observe in terms of the origin and destination demand? And at the bottom, we did a little thermodynamics to understand how people choose their routes. And we were able to predict it with a certain level of accuracy. And all these we combined to build that simulation platform that you saw just now. So what does this mean? You can conduct scenarios. Again, sorry, this is supposedly for a scientific conference, but I hope you can bear with me. X-axis, are you with me? X-axis tayo. X-axis is population in millions. Y-axis is the average travel time for the first one. The second one is the number of commuters who missed the train. And the third one is the total missed trains. Okay, so what did we do here? We simulated what if there were 2 million commuters. So ito yung average travel duration. This is the commuters who missed the trains, and these are the number of missed train events. And then we increase it. What about 4 million? What will happen? What about 5 million and 6 million? Then we can tell the government or whoever who is concerned with the MRT system that, hey guys, you know what? The tipping point of your train system is at 2 million. Anything beyond that, you really have to change your MRT system because the penalty increases exponentially. So you see, that is the power of data-driven decision making. Are you convinced? Yes. Okay, that's good. This is another example. What they did here was, what if we release a promo wherein if you travel from 6 a.m. to 7 a.m., you get a free ride. So many people would shift their travel time. So instead of starting at traveling at 7 a.m. Since you're getting a free ride, you will move your travel time to 6 a.m., right? And then the question that we ask is, what is the ideal participation ratio? What does that mean? Of course, you don't want 100% of the people to move their travel time to 6 a.m. What's the point? It will still be congested. So there is that sweet spot that we were only able to extract because we had models, right? And the sweet spot was at 20%. 20% lang. We only want 20% of the people to change their travel time. Not everyone, not 25, not 30, but 20%. So you see, you cannot see all this if you don't have a data-driven model. Fine, you can use your intuition. It's okay. But I think it's much smarter if you use a data-driven model. And, you know, again, as mentioned earlier, data science or big data analytics is getting a lot of traction here in our country. I think beginning last year, but even a few years ago, there were some groups who have already started these data science efforts, but only last year that our government started really investing in it. It's because of Industry 4.0. This is the Internet of Things. You know, we're afraid that the BPO industry will suffer. And then the question is, how are we going to prepare the Filipino people? How are we going to prepare our economy? That's why we have this data science thing. Now, I'm sure all of you here are convinced of the power of a data-driven strategy. Are you all convinced? Yes. All right, that's good. But what are the challenges? How come AIM is the first to offer this graduate program? Why? What happened to the rest? What are the challenges, right? So, Alvin Lau, are there any traders here in this room who trade stocks? None? One? Anyway, if you're following DNL, it's the biggest chemical industry in the country. All right, it's the largest one. And Alvin Lau is its president and CEO. So in May, I sent Alvin a Facebook message asking him, hey, what do you think of the data science and big data analytics and how it will impact the different manufacturing industries in the country? And this was his reply. He said that being a statistics major, he believes, like most of you, in the power of big data. It's just that he doesn't think that any manufacturer here in the country does it right yet. And probably not just manufacturing industries, other industries as well. Okay? And he said that we need someone to teach us. That was a really inspiring statement from him. Okay, this was in May. I was still in Singapore. Okay? And yeah, in fact, not just Alvin Lau, but also other companies. I've only been here 2 months. Chris has only been here 2 weeks. And we've already engaged these companies. And what is their problem? They all know about data science. Their problem was there are no data scientists here. A lot of you can do machine learning. A lot of you can do AI research. But if you sit across a CEO, a CTO, or a CIO, most of you will be mum, right? Isaac? Right. All right. So this was one of the drivers of why we're starting this first Master in Science and Data Science at AIM. I'm pretty sure you've seen all these graphs before. This MRT train line is just a train line for the different topics that you need to know at the very least when you talk about data science. And you've seen this graph before, right? Yeah, so that's data science for you. But these are also the things that you can just learn online. Do you agree? Udacity, Coursera. That's also why, you know, you can see this is Forbes report. They said that a lot of companies do this data-driven research, but the problem is only 29% are successful because scientists couldn't link between the data result and the business value. So the term there is business. This is why you're at AIM now. So what we're offering at AIM, aside from the scientific rigor that we're going to teach the students, we're also going to be teaching all these soft skills. And hopefully we can partner with DataSeer or other companies or groups here in the country. You will be learning the students will be sitting in MBA classes like business and management, the basics, language of business, communication, teamwork and collaboration, and analytical and critical thinking. I'm actually almost done. But I hope to sign up. There's a sign up, right, for your community. I'm not yet part of it, but I saw that there's around 2,000 plus of you. So I hope to join you in the future sessions. Thank you for having me. Have a good evening.